All right, this is the pre-video for Tuesday of next week's class about radical equations and equations that are in quadratic in form. We're going to look at the radical equation part on the video, and we will do the quadratic in form obviously in class still. So a radical equation are equations that contain variables in the radicand, which remember means the part under the radical symbol, such as this one is the square root of 3x plus 18 equals x. Square root of x plus 3 equals x minus 3, square root of x plus 5 minus the square root of x minus 3 equals 2. So these are three different versions of what a radical equation could look like. And it doesn't have to be a square root. It could be cubed root, fourth root, any of those. So radical equations may have one or more radical terms and are solved by eliminating each radical one at a time. We have to be careful when solving radical equations because when you use the rule we're going to use in just a second called the power rule to get rid of our radical, that is not creating an equivalent equation, it's creating a similar equation. And that's the problem we got when we cleared out denominators too, when we were doing rational equations, is that sometimes you'll get an extraneous solution, which means that there are solutions to the similar equation but not to the equivalent original equation. It's not due to a mistake in the solving method, but it results from the process of raising both sides of an equation to a power. However, if we check each answer in the original equation, we can confirm which ones are the true solutions. So here's our steps essentially that we're going to go through. It says, given a radical equation, how do you solve it? Isolate the radical expression on one side of the equal sign. Put all the remaining terms on the other side. If the radical is a square root, then square both sides of the equation. If it is a cube root, then we'll raise both sides of the equation to the third power. So if it's an nth root, we'll raise both sides to the nth power. And doing so will eliminate that specific radical symbol. Solve the remaining equation. If a radical term still remains, which means you would have had more than one to begin with, we will repeat steps 1 and 2. Confirm your solutions by substituting them into the original equation. So we're going to look at a couple of these together in this video. Starting with the very first one here, it says this is solving the square root of 3x minus 5 equals 1/4. There's one radical in this equation and it is already isolated on this side by itself. If there was like a +2 here or something in front, we would need to isolate. So we're going to raise both sides to the squared power to get rid of that square root. So this becomes then 3x minus 5 because the square and square root cancels out. But this side does not have a square root, so we have to square both the 1 and the 4. So that'd be 1/16. Next step, I would take that equation and I'm going to multiply both sides by 16 to clear out that denominator. So this would be 48x minus 80 equals 1. Add the 80 over, and that would be 81. Divide by 48. So then the question is, does that reduce? And they're both divisible by 3, so let's see what that gives us. So 81 divided by 3 would be 27. 48 divided by 3 is 16. And that does not reduce any further, but we don't know for sure that this answer is actually correct, so we're going to check it. So we plug it back into the original equation that we had. So square root of 3 times 27/16 minus 5 equals 1/4. We need to make sure that the left side actually will end up equaling 1/4. So we have to multiply 3 times 27 because that's like 3/1. So that makes 81/16. I'm going to go ahead and write minus 5/1 because we're going to get a common denominator. Common denominator would be 16, so 81/16 minus times top and bottom by 16 of that would be 80/16. Then we subtract, so that's 1/16. And the square root of 1 is 1, the square root of 16 is 4. And you can use your calculator to help you out, but you have to do the check to prove that this solution is correct. So that's the first one. Part B is a slightly more advanced problem. This is one where we have a x over here on the left side that we need to move first because it is keeping us from being able to isolate that radical. So I'm going to add that x to the other side first. So I have x and then a +3 because remember the x moved over and became positive. We're going to square both sides to get rid of the square root. Now, why this one's a little more complicated is that this is a binomial squared on the right side. So that means you actually need to write that twice and FOIL it out. The left side, the square root and the square cancel. So this is 3 minus x equals x squared plus 3x plus 3x plus 9 after I FOIL. 3 minus x equals x squared plus 6x plus 9. This is quadratic, so we want to get everything moved to one side. So I'm going to actually move everything over to the right side because I like that my x squared is positive. So I'll add 1x over to join the 6, so that would be 7 x's. And I'll subtract 3 over to join the 9, so that would be plus 6. This would then factor into an x plus 1 and an x plus 6, multiplies to 6, but adds to 7. So I get the solution of -1 and -6. Now, before I go circling those and saying, yay, I have my solutions, I need to check both. So the square root of 3 minus a -1 minus a -1, so we're plugging it back into this original equation, equals 3. 3 minus a -1 would be 4, because it'd be 3 plus 1. This will be also plus 1. Square root of 4 is 2. Sorry, drop the radical. Plus 1 equals 3. So that one does work. So we know that -1 works. Square root of 3 minus a -6. Subtract a -6 equals 3. This would be square root of 3 plus 9. Or sorry, 6. Trying to do this too fast. Plus 6 equals 3. That would be square root of 9 plus 6 equals 3. That is 3 plus 6, which does not equal 3. So this scenario does not equal the correct number. So the only solution is x equals -1. So that's why it's important to check those extraneous possibilities. Just because you got a solution after raising something to a power does not mean that it's going to work in the original equation. And the reason for that is when you square a -2, it becomes a +4. When you square a +2, it also becomes a +4. We don't know which one of those originally would have been equal, like a -2 and a 4, or a -2 and a +2 set next to each other aren't actually equal, but they square the same. So that's why you get those extraneous solutions. All right, we're going to do one more on this video, and that'll leave us the harder one to do in class, which has the 2 radicals. So let's look at this one. Again, we don't like that the radical is mixed in with some other stuff. If it was me, I would actually add the 2 over, and I would add this square root over. Now, when you add the square root over, it does change this from a negative to a positive on front, but it doesn't change anything about the inside of the radical because you're adding that as a term. Then we're going to square both sides. So this would be x plus 2 times x plus 2. This is -7x minus 24. I get x squared plus 2x plus 2x, that'd be plus 4x's, times 2 would be 4. Gonna add everything over to the left. So I get 11x and a plus 28. This factors into an x plus 7 and an x plus 4. So I get -7 and -4. Now, here's another trick I'm going to show you. When you're doing your check, you don't have to plug back into the original if you've carefully moved things. You can always plug into the version where the radical is isolated, but again, you have to have moved things correctly to do that. That's sometimes just a little quicker for the check. So -7 plus 2 equals the square root of -7 times -7 minus 24. This is -5 equals the square root of 49 minus 24. I already know that this is bad because the square root should equal a positive number on the other side. So -5 equals the square root of 25. The square root of 25 is not -5 unless there's a negative in front of the radical. So this is actually not equal. So -7 is not a solution. And the same thing is going to happen with this -4. It also does not work. So if both of your solutions or all of your solutions cancel out as being not good, then you know that this is a no solution problem. So we get -2 equals the square root of 4, and square root of 4 is +2 since that's the principal root. There is not a negative in front of that root. So if both of them fail, then the answer is no solution. All right, so that is the video. On class time on Tuesday, we'll start off with the solving the radical that has 2 radicals in it. and then we'll move on to our rational exponents and then the quadratics in form. And I am moving some of the homework, and that's going to be posted in the same announcement as this video. Have a good night.